Welcome to GK Tech Course. Let's dive in. You might think Java basics are easy, but interviews are failed exactly at this level. Simple questions, confused answers. Let's fix that. The first question, what is Java and what are the main features of Java? Java is a high-level object-oriented programming language which is developed by Sun Microsystems in 1995. The main reason Java became popular is because of its platform independence. It follows the principle write once, run anywhere. It means when we write Java code, it does not directly convert into machine code. Instead, it is compiled into bytecode. The bytecode runs on the JVM, which converts into machine level instructions depending on the operating system. That is why the same Java program can run on Windows, Linux, or Mac as long as JVM is installed. The main features of Java, such as object-oriented, platform-independent, simple, secure, robust, multi-threaded, portable, and high performance. These features makes Java suitable for enterprise applications, banking systems, web applications, Android development, and microservices. So the next question is, what is JDK, JRE, and JVM? What is the difference? So this one is very important topic, and every Java developer must know these terms. Okay, so JDK stands for Java Development Kit, which contains JRE, compiler, debugger, and development tools, basically which is used to develop Java applications. JRE stands for Java Runtime Environment. JRE contains JVM and core libraries which is supporting for run Java programs. Okay, and this is not for development, it is only for run the Java program. So the JVM stands for Java Virtual Machine. So this is very important, which is actually executes the bytecode and converts bytecode to machine code, and also which is manage the memory and garbage collections. Okay, and the very important point, JVM is platform independent. So JDK, what it will do, using JDK you can write and compile .java files. Okay, so when you compile this .java file, so which is generate .class files. If you see in your programming folder, you will see once the application runs, so .class file will generate. It means JDK compiles your .java files to bytecode, which is in .class files. Now JRE will run that .class files. Okay, and if you see here, so Java compiler will convert to bytecode, and Java runs using JVM. If you see here the picture, first Java source code which we are writing in a .java extension file, and JDK using compiler, it will convert to bytecode, so which is in .class file. And next JRE and JVM, which help us to execute engine, and which is basically convert bytecode to machine code. What is JVM? So we will discuss more about JVM in detail. JVM stands for Java Virtual Machine. It is a virtual machine that runs Java bytecode and converts into machine code. We discussed earlier. So JVM provides platform independence by allowing Java programs to run on any system where JVM is installed. Okay. It is also manage memory, garbage collections, and execution of Java programs. So why JVM is important? Because it makes Java platform independent, it handles memory management, it performs garbage collection, it provides security checks, it loads classes into memory. What are different memory areas inside JVM? So you already know the JVM memory is divided into different areas to manage program execution, right? So the main memory area, method area, heap, stack. So we'll see this simple code here. So we have created one class, okay, demo, and we have declared one static variable, okay. So this static related memory is stored into method area, and we have a main method here. So primitive data types like local variables will store into stack memory, and the object will be part of heap memory, right? So we will discuss more in detail, right? So what is method area? So basically, so which is actually stores class level information, okay, and store static variables, store method, bytecode shared among all threads. So this method area will be available for all threads, okay. And the heap memory is basically which stores objects, okay, and this is also shared among all threads, okay, and which is managed by garbage collector. The object, like here, student, is stored in heap memory. Heap is the largest memory area. Coming to another area, which is stack memory, which stores local variables, okay, and stores method calls. Each thread has its own stack. It's very, very important. And when method ends, stack memory is cleared automatically, right? So here this local variables will be stored into the stack memory, and this method, okay, show, will be part of stack memory, okay. Next question is explain the structure of basic Java program. So every Java program will have package declaration, and import statements, and your class declaration. So inside a class you will have your methods and statements, right? And every Java program must contain at least one class. This is very, very important. Every Java program must contain at least one class and a main method as the entry point for the JVM to run your program, okay. Class name must match file name, and main method must be public, okay. Only one public class per file. Execution always start from main method, okay, and package and imports are optional. The next question is explain public static void main method. So this is the main entry point of your Java program. See, the JVM starts execution from this method only. So JVM always look for your main method, and the method signature must match with this public static void main, and which is accept string of array args, okay. So the JVM internally have the program, and which call your main method, okay. That's why we declared as a static, because we already know static blocks will be belongs to class, not for your object. So you no need to create an object, you directly call your main method, okay. So the public stands for which is then a access modifier. So JVM must access this method from outside, right? So that's why it should be public. If it is not public, JVM cannot call it, okay. So interview tip here, so JVM is outside the class, okay. That's why the method should be must and should public. And static, so this is belongs to class, not object. So JVM can call it without creating object, okay. If it is non-static, we would need to create a object first, right? And void means which does not return any value. So JVM does not expect any return value. Main, so predefined method name. So JVM looks specifically for this method. If name changes, program won't run. So this is very important. Method signature should be match same as it is, okay. And string array, which is actually used to pass command line arguments. You can pass the input argument, okay. And this is a variable name args, okay. You can keep different name, that's not a problem. but it should be string up array. Okay, and allows user input during execution. Can we overload the main method? So this overload, the overload belongs to the oops concept. We will learn deep about overload methods. Okay, but the question is here, can we overload the main method? Yes, answer is yes. We can overload the main method in Java. However, the JVM will only execute the main method with the same exact signature should match. Okay, other overload method we can call it manually from inside main method. So here if you see here, this is actually the main method which JVM can understood. Okay, and the other overload method we have written. So here, so what is basically overload method? You can keep your method name same, but different parameters. Okay, so here if you see, the main method is having string array is the input parameter. Here it is a data type is int. Okay, this is called overload. So the main method, yes, you can overload the main method, but JVM always calls the main signature matches. Okay, you can call other overload main method from inside main method main. Okay, the next question is, can we override the main method? Previously we learned overload, now it is override. So these terms like this terminology overload, override, which is a under oops concept, we will learn deep about in oops concept. But here the question is, can we override the main method? The answer is no. We cannot override the main method in Java because it is a static method. Yes, this main method is static method. We already discussed these static methods belongs to the class, not to objects, and overriding works only with instance methods. This is very important. As a Java developer, we should know static methods, static variables are belongs to the class, not for objects. Okay, and overriding will works only with instance methods only. However, we can hide the main method in a subclass, but that is not true overriding. Okay, so this method hiding we will learn in the oops concept. But the answer for this question, can we override the main method? The answer is no. What are primitive data types in Java? So in every programming language there will be data types, right? In Java, so we will call it as primitive data types. So these are the basic data types in Java that store simple values directly in memory. Java has 8 primitive data types here. So if you see here the list, byte, short, int, long, float, double, char, boolean. So these are the primitive data types. So unlike objects, they store actual values rather than reference. So we discussed in JVM, there will be a stack memory. So they all the primitive data types that will store their variable name and values. Suppose let's say int x equal to 10. So x and value 10 will be stored in stack memory. Okay. So there are exactly 8 primitive data types. They are not objects. So these are the interview points you can remember. Okay. Cannot call methods on primitives. Wrapper classes exist for each primitive. So this is the important one. Wrapper classes we will discuss in the next question. Okay, each primitive data type will have one wrapper class. Okay, wrapper class will be looks like int primitive data type will have an integer wrapper class, double will have a double wrapper class. Okay, we will discuss deep in the further question. So here if you see in the main method we have declared all the primitive data type and we assign the values. So as we discussed, these will be stored into the stack memory. Okay, and the variable name and the values directly stored into the stack. Okay, it's not like object. So if it is a object, like if it is a student class, student is having age, which is instance variable. Okay, when you create a object, student object, and you set the student age is 25, then what will happen? Student object will create in the heap memory and value will be stored into the heap memory, but the variable name age will be stored into the stack memory, and which is referent to the heap object. That is the difference. What are non-primitive data types? Previously we learned primitive data types. Now it is non-primitive data types. Non-primitive data types in Java are reference types that store the memory address of objects instead of actual values. So these are the non-primitive data types: string, arrays, classes, interfaces, objects. Okay, unlike primitive data types, non-primitive types can store multiple values and have methods. So like string, if you take string, we have methods like string equals to uppercase, lowercase. So these are the methods. So these reference types will have methods. Non-primitive types are also called reference types. Okay, because they do not store actual value, store reference. Okay, memory address are created using new keyword. Right, so whenever you use new keyword, which is actually creating an object, so obviously this object will be stored in the heap memory. So another question from the Java basic is, what is typecasting in Java? So typecasting is nothing but it is a process of converting one data type to another data type. So there are two types of conversion: implicit and explicit. So if you see implicit typecasting, so basically the typecasting is mainly used with the primitive data types. Okay, so implicit typecasting will happens automatically. Why? Because smaller data type to larger data type conversion. Okay, so here no data loss will happen. If you see this example, okay, we have created a int variable a equals to 10. Okay, we are assigning this int to double. So here we are converting like smaller data type to larger data type, so automatically this conversion will happen. So this is called implicit data type. And memory also, if you see here, int will have 4 bytes and double will have 8 bytes, so that safe conversion will happen. And the another one is explicit typecasting. So here what will happen, we are converting large data type to smaller data type. So when you are converting large data type to smaller data type, there will be a possible data loss. This example, if you see, we have declared a double value. Okay, so 10.75, but here we are converting to int. So here if you see, the conversion should happen manually. So what we are doing, we are forcefully saying, okay, this is int. Okay, so when you are converting double value to int, we are doing a casting here. So this is explicitly we are doing the casting here. Okay, and so here if you see, the output will be 10. So the decimal part of 75 will lost. Okay, so decimal part lost. So memory also, if you see in the memory flow, double will occupy 8 bytes, int occupying 4 bytes. So possibly there will be a data loss. Okay, and this will be manual cast required. See, the hierarchy will be like this one. So byte to short, short to int to long, long to flow, flow to double. So this will be Java automatically promotes from left to right. Okay, so important. is here what are access modifiers in Java. So before we jumped into interview question, so we should know the access modifiers in Java. So access modifiers in Java define the visibility or accessibility of a classes, variables, methods, and constructors. Okay, Java has 4 access modifiers, which is private, default, protected, public. Basically, they control where a member can be accessed within class or package, subclass, or everywhere. Okay. So detailed explanation here. Access modifiers help in encapsulation, security, controlling access, reducing unwanted usage. Private access modifier basically accessible only within the same class. This is a very important. Private access modifiers, when you declare any method or variable as a private, okay, you can access within the class only. Okay, basically we use this private access modifier for strong encapsulation. Default, so accessible within the same package, okay, not accessible outside the package. Okay, here you mentioned, so without mentioning any access modifier, by default it will be default. Okay, when you say protected, so which is accessible within the same package and accessible in subclasses in a different package, used mainly for inheritance. Okay, and the public access modifier will be accessible from anywhere. So whenever you declare any method or no variable as a public, so you can access from anywhere. There is no restriction. Okay, so here is the table will show you each question from the Java basic. Difference between instance, static, and local variables. So in Java, instance variables belongs to an object, static variables belongs to class, local variables are declared inside method and exist only during the method execution. Okay, they differ in scope, memory, location, and lifetime. Instance variables, like when you declared inside a class but outside method, each object gets its own copy, right? So here is the example. So if you see student class, you declared a one variable which is instance variable. So you can create as many objects here, student s1, s2, s3. Okay, each object gets its own copy, right, stored in heap memory, and which is lifetime as long as object exists. Static variables declared using static keyword, shared among all objects, only one copy per class. We already know stored in method area, right? So in the JVM, the execution flow, the static blocks will be stored in method area. So all objects share same school name. Here if you see, even you create a multiple object, student object, but the school name will be remain same. Okay, which will load only one time. So static variables, static blocks will be execute only one time, even you create a multiple objects. Local variables declared inside method, constructor, or block. Scope limited to that method block and stored in a stack memory. No default values. It will be like until method execution, these will be available in the method area, memory area. Okay. Public void, here example, if you see int number we have 10, we have assigned. This is a local variable. Okay. We have created a class demo. So we have declared no instance variable and the static variable, and display function will have local variable. So instance variable will be per object, static variable will be shared, local variable will be method only. Thanks for watching GK TechVerse. Subscribe, stay consistent, and keep upgrading your skills. See you in the next video.